Again, welcome to Introduction to Data Mining, ITS 632 course. So in these lectures, we're going to cover the measures of similarity and dissimilarity. This is the same concept we are going to follow in cluster algorithm. So again, these lectures cover our course textbook, chapter 2, section 4. So first we start with similarity. Here we say similarity is the numerical measure of how alike two data objects are. So the concept is the same as cluster algorithm. If we have two data sets or we have two values that are similar, they will be clustered together. So items that are similar will be in one cluster. Items that are dissimilar will be in different clusters. So again, similarity is the numerical measure of how alike two data objects are. Now, the measurement will be higher when the objects are more alike. Often, it falls within the range of 0 and 1. Dissimilarity means when two data objects are different, are dissimilar, in cluster algorithm, they will be in different clusters. So if we have data objects that are similar, they will be in the same cluster. If they are dissimilar, they will be in different clusters. So numerical measure of how different are two data objects. Here we say lower when objects are more alike. And also the minimal dissimilarity is often 0. Then upper limit also again varies. It depends on the application or implemented algorithm. So proximity refers to similarity or dissimilarity. So again, as we said earlier, the whole concept of this section, we will go more details when we start cluster algorithm. Our next lectures will be the first algorithm we are going to cover will be the classification. Then from classification, we go to association. And our last algorithm section will be clustering. So again, for convenience, as we said, the term proximity is used to refer to other data objects are similar or dissimilar. Now, since the proximity between two objects is a function of the proximity between the corresponding attributes of the two objects. So we're first going to describe how to measure the proximity between objects having only one simple attribute. And then we're going to consider the data object having again multiple attributes. So similarity and dissimilarity for simple attributes. Here we have P and Q are the attribute value for the two data objects. So the attribute type either can be nominal, ordinal, interval, or ratio. So we say the level of measurement of attributes. So now if it's nominal, then the dissimilarity D will equal to 0 because P is the same as Q, which means if we are measuring dissimilarity and we have two attributes that are similar, then the value will be the minimum, which is 0. Now, if they are not similar, if P is not equal to Q, then the answer will be 1. Now, in terms of measuring the similarity, if P equal to Q, which means they are similar, then it will be 1. Then if they are not similar, then the value will be 0. So with ordinal, the dissimilarity will be P minus Q over N minus 1. So P and Q is our attribute. We want to find if both of them. So you can see that from the formula, if P is the same as Q, then our answer will be 0. 0 divided by any value stays 0. So this means if they are similar, we will still get 0. So D equal to P minus Q over N minus 1. N will be the number of values we have. In terms of, we can use the term the number of samples, but that's the number of values. Now, when we are finding the similarity, it will be, now here we are finding the similarity. So P minus Q, if it's 0, then everything here will be 0. So similarity means our answer will be 1, if P and Q. So dissimilarity means our answer will be 0 if P is the same as Q, because P minus Q is 0, 0 divided by any value is 0. And also P minus Q, if they are similar, is 0, 0 divided by anything is 0, but 1 minus 0 is 1. Now, if it's interval or ratio, then the difference of P and Q, absolute. So it's the same thing now. If they are similar, the answer will be 0. If they are dissimilar, we may get some values. Depends. Then if we are looking for the similarity, then S will give us either negative D. So S is 1 over 1 plus D, or 1 minus D minus the minimum value of D over the maximum value of D minus the minimum value of D. So the next is going through the Euclidean distance. Euclidean distance is one of the common and most popular formula in finding the distance between 2 points. And we use this formula a lot in college algebra. So here we say Euclidean distance is when n is the number of dimensions, which is the attributes, and p, k, and qk are respectively the kth attributes or the components or data object p and q. Then we have the distance to be square root of the sum of k from 1 to n. Again, n tells us the number of attributes we have, which we normally use the term the dimension. So it will be k minus pk minus qk. That's the difference. Here we are assuming we have 2 points, which is 2 attributes. Again, the number of k's we have depends on the dimension. So it will be the difference of the 2 attributes, all square. And we sum, or let's say if it's 2 dimension, then we get P1 minus Q1 plus all square plus P2 minus Q2 all square. The sum here means we sum everything, then we find the square root. So this is an example of Euclidean distance. We have 4 points and we want to find the distance between the points. So we can find the distance between P1 to P2, P1 to P3, P1 to P4, P3 to P4, P3 to P2, P2 to P4. And that's what we use the table here for. So we have P1, P2, P3, P4, and these are their X and Y values. We can see that the P2 is on the horizontal line, so this means the Y value is 0, but S value is 2. P3, S value is 3, and Y value is 1. This is 2 dimensions and Y. So the table here represents the points on the plane. Now we can find the distance between P1, 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 P2, P1, P3, P1, P4, and that is the value using the Euclidean distance formula. So first the P1 and P1 will be 0 because we have the same value. So it's 0. And the rest, again, we're using the Euclidean distance, we can find the points. So where we have the P1 to P1, P2 to P2, there, so the diagonal section, everything will be 0. Because the distance from P4 to P4, there's no distance, it's just the same place. Then the rest of the value, I will plug in to find the distance between P2 and P1, we have 2.828. This means based on the values we have here for the S and Y for P1, P2, we will find the difference of the values, square 2 dimension plus the second values, difference square, then find the square root of it. Also, we have what we call the Minkowski. Minkowski distance is almost the same as Euclidean distance. Here we say it's the generalization of Euclidean distance. And this is the formula, so we can see the difference of 2 points, pk minus qk, but it's absolute, so we have to get positive answer. The dimension from 1 to n, the sum to the r, then everything raised to the power of 1 over r. Now, in the Euclidean distance, we are using 1 over 2 square root. But here in Minkowski, the value of r will depend whether it's square root, cube root, etc. So the r normally is the parameter. So if the parameter is 2, then it's square root of everything, then it's the same as a Euclidean distance. But again, the parameter can be 3, 4, any amount. And also the n is the number of dimension, which is the number of attributes we have. And pk and qk are the attributes. So again, this formula is almost the same as Euclidean distance. And the difference is the square root. Euclidean distance, we always use everything raised to the power half, which is square root. But with Minkowski, the r depends on the number of parameters we have. So this is an example of Minkowski. Same concept, the same data points as the example for Euclidean distance. So here we use the formula again to find the values between the 2 points. We also have another distance measurement. And in this method, which is called the Mahalanobis distance, again, Mahalanobis distance, we find the covariance matrix of the input data, x. So we can see p minus q to the power t. This is the finding the covariance. And the sum raised to the negative 1. So the concept here also is like finding the distance between 2 points here, as we can see on the plane. So these are some of the common properties of a distance. Distance such as the Euclidean distance have some well-known properties. So we say the distance between P and Q should be greater than or equal to 0. If the distance So as we said again, the distance such as a Euclidean distance have some well-known properties. For example, the distance between P and Q should be a positive value. And if P and Q equal to 0, it means P is the same as Q. So here we say the distance between P and Q is greater than or equal to 0 for all P and Q. And the distance P and Q is equal to 0 only if P is the same as Q or P equal to Q. Also, the distance between P and Q is equal to the distance from Q to P because they are symmetry. Again, P is a point on the plane, Q, they are not moving. So the distance from P to Q should be the same as the distance from Q to P, which is symmetry. Also, the distance from P to R should be less than or equal to a distance P to Q plus the distance Q to R. For all points P, Q, R, this would be a triangle inequality. And the similarities also have some well-known properties. If we have a similarity of P and Q, the answer is 1. That's the maximum similarity. Also, similarity of P and Q is the same as similarity of Q and P because the points on the plane are symmetry. Now, similarity between binary vectors. Here we say the common situation is that objects P and Q have only binary attributes. So binary attributes is attributes that have only two outcomes, maybe true, false, 1 and 0, etc. So to compute similarity using the following quantities, let's say we have M sub 0, 1, that would be the number of attributes where P was 0 and Q was 1. We have M10, the number of attributes where P was 1 and Q was 0. M00 means the number of attributes where P was 0 and also Q was 0. M11 means the number of attributes where P was 1 and Q was 1. So again, we are going to use this method to do one example here. So SMC stands for the simple matching, and also the J stands for Jaccard coefficient. So now to find the simple matching, it will be the number of matches divided by the number of attributes. So the number of matches will be 1100. So we had the M11 plus M00 divided by all the total attributes. In terms of Jaccard, it will be the number of 11 matches divided by the number of not both 0 attribute values. So it will be M11 divided by M01 plus M10 plus M11. So we have P and Q, we have binary values, 1000, etc. So M01 will give me 2, which is the number of attributes where P was 0 and Q was 1. And M10 equal to 1, which is the number of attributes where P was 1, Q was 0. Then M00 is 7, which means the number of attributes where P was 0, Q was 0 is 7. And M11 will also give us 0. So here, to find a simple matching, it will be M11 plus M00 divided by all the attributes. And these are the values they gave us. So we're going to M11 is 0, M00 is 7 divided by 2 plus 1 plus 0 plus 7. So the answer will be 0.7. Now to find the Jaccard coefficient, it will be M11 divided by M01 plus M10 plus M11. So that will give us 0 divided by 2 plus 1 plus 0. So the answer will be 0. We also have the cosine similarity to measure the similarity between two points. So here, if D1 and D2 are two document vectors, then the cosine D1, D2 will be D1 vector multiplied D2 divided by the absolute D1 and D2. So the dot indicates the vector dot product. And this is the length of vector D. So we have a value for D1 and D2. We can find the cosine similarity. And the cosine similarity will be D1 vector dot product D2. And we put in the value, so 3 times 1, 2 times 0, plus 2 times 0, plus 0 times 0. Plus this is a vector. A vector means we have attribute of values. D1 have 10 values, D2 have 10, and they match each other. So we get 3 times 1 plus 2 times 0 plus 0 times 0 plus 5 times 0 all the way down to the end. And when we do that, we will get 5. Then we can also find the D1 and D2, which is the length of the vector D1 and D2. Then if we know these 3 values, we can plug in the formula for cosine, and our result was 0.3150. So to find D1 is that you square all the values and you sum it. So 3 times 3 plus, 2 times 2 plus, 0 times 0 plus, 5 times 5 plus, 0 times 0 plus 0 times 0 plus 0 times 0. So again, all the values here, we square them, then we find the square root of it. So raised to the power 0.5. The same thing with the D2. Square each value, then you sum all, then you find the square root of it. Then when we get the value, then we divide the D1 vector dot product D2 divided by the length of the vector D1, D2, multiplied by D1 and D2, which is the formula here. We also can find a correlation, and the correlation will be the measures the linear relationship between objects. So to compute a correlation, we standardize our data object P and Q, then take their dot product. So the formula is given here. So this is the mean of P divided by standard deviation of P. Pk minus mean of P divided. Then with the Q section, Qk minus the mean of Q divided by the standard deviation of Q. Then if we know the two values, then we can find the correlation of P and Q, which will be the dot vector product. So this is an example of a scatter plot with a correlation. Decreasing means it's negative. The correlation values is always between -1 to +1. Increasing relationship, we can see that we have positive values. Now here is 0, we don't have any relationships, just scattered everywhere. So again, correlation, PSC correlation, the value is between -1 to +1, and it's linear. We have increasing and also decreasing relationship. Increasing relationship means when the variable of the horizontal increase, the vertical variable also increase. This decreasing relationship means when one of the two variables increase, the other will decrease. And the opposite also. And the concept of density, we have a density algorithm in cross-story. We will go more detail on density in cross-story. So here we say the density again is based on cross-story algorithm, which require the notion of density. So example can be Euclidean density. So Euclidean density will be the number of points per unit volume. Remember, we find the distance between two or more points. So to find the density, Euclidean density, it should be the total number of points within some volume or within some range. We can also find the probability density and also the graph-based density. We will cover this more details again in cross-story algorithm. So let's start with the Ukrainian density, which is also called the cell-based. So this is the simplest approach, is to divide the region into number of rectangular cells, as we can see, of equal volume, and define the density as the number of points the cell contains. So here we have some data set on the plane. We can divide all the data by the number of cells, the cells in the plane. Then we measure or count all the points in each cell. And that's what we have here, point count for each grid cell. So we can see that the most density is 27. And of course, the less density is 0. So Euclidean density is a center base. So here we say Euclidean density is number of points within a specific. So let's go through some few examples here. Here we further explore the cosine and also the correlation measures. The first question is, what is the range of values that are possible for the cosine measure? It should be between -1 to +1. Many times the data has only positive entries. In this case, it will be the range from 0 to 1. Now, if two objects have a cosine measure of 1, are they identical? Here we say it's not necessary. It sounds like they are identical. It's possible, but it's not necessary. But all we need to know is that the values of their attribute differ by a constant factor. And also, what is the relationship of the cosine measure to correlation, if any? First, here we have to look at our stat measures, such as the mean, standard deviation, in case where cosine and correlation are the same and different. So for two vectors x and y that have a mean of 0, the correlation xy equal to the cosine x and y. Now, for the following vectors x and y, we should calculate the indicated similarity or dissimilarity measures. So we have x to be 4 dimensions of 4 values, y also is 4 values. And now they say we should find the cosine, correlation, and Euclidean. The cosine, the answer will be 1 based on the formula, because here we have x and y. Correlation will give us 0. It's undefined. And Euclidean will give us 2. Now the second we have 0, 1, 1, and 0, 0, and 1, 1, and 0. So the cosine will be 0 still. The correlation will be -1, because when 1 increase, 1 decrease. And Euclidean distance will be 2. And also Jaccard coefficient will be 0. So this will be the conclusion of our lectures on the concept of similarities and dissimilarities. So again, in these lectures, it's the same concept as cross-term algorithm. Our goal is to find a similarity and dissimilarity between two data objects. And we saw different methods that, again, we can use. So again, wish everybody the best, and we see in the next lectures. Next lecture will be our chapter 3 of the course textbook, which is exploring data. So we'll start with the summary data, then visualization also of data. So again, wish you the best. Thank you.